Hi, this is Dr. Curtis Livesey with Dynamite Ag, and today we are going to run the 360 soil scan. We're on a farm between Mount Pleasant, Iowa and New London, Iowa, and we're out in the field right now gathering the samples. And what we're doing is we've got, as you've probably seen on Facebook, Twitter, wherever else, the board that's set up with holes every 3 inches all the way across the row. And the reason that we're doing that is so that we can see exactly where the nitrogen is. So when we talk about broadcasting nitrogen, or rather applying nitrogen, X number of pounds per acre, that's a little bit of a misnomer because that does assume that we're getting a uniform distribution. But if we're side dressing in the middle of the row, what we've found in doing this kind of research is that it tends to stay concentrated right in the middle of the row. And that's whether we're talking about anhydrous ammonia or UAN solution, or if you're banding urea, for instance. But the particular grower that we're working with today, Scott actually has a strip till situation, so he's banded his nitrogen directly under these plants or close to the base of the roots of these plants. So we're still going to run the same situation where we take samples every 3 inches all the way across the row, and then we're going to run those individually to see how the concentration of nitrogen will actually vary based upon where you're at in the row. We're back at the truck now, and we've got the samples that we just pulled from the field. We've mixed those thoroughly in the bag here, and then we use the scoop that comes with the 360 soil scan. It's a pre-measured size, and we're going to put in 2 scoops of soil in here, and then we're going to start running these samples. Now, as you can see with all the soil bags up there, we've got several samples that we're going to run. So this is going to take a little while to do. Running a single sample usually takes somewhere in the neighborhood of 3 to 5 minutes. But once we get the measured scoop in there, we put it up here in the mixing rod. And you do have to work with it a little bit sometimes, depending upon the soil type and how heavy it is. This has got, I'm guessing, a fair bit of clay in it. It's got some good moisture in it right now, so it's a little bit sticky. So we twist until we get that on where we need it. And then we use our iPad, which connects through Bluetooth. I was going to say wirelessly, but it's actually through Bluetooth. And you notice that there is a plug-in you can use. If you want to charge your iPad, you can do that at the same time, but you don't actually have to have it connected to the soil scan to run it, which is kind of a nice feature. We're obviously on the back of the pickup here. I just picked up one of the Superstart power packs, and the soil scan does come with both the cigarette lighter plug-in as well as like a normal wall unit as well. So we've got that out. We're going to run it here in the back of the truck in the shade, as you can obviously see. We hit the button that says mix soil, and it's going to put in a pre-measured amount of water equal to the amount of soil that we put in. It's going to mix that up on the mixing rod, and then we're going to run that through the nitrate test. As it's doing that, we've got several options. We can start mixing the other soil. Right now on the first sample, I'm actually going to go through a labeling process so we know which farmer this is, which farm that it came from, things like the sample ID and the sample depth, etc. And it's going to save all this information so we can come back to that later in the growing season if we want to. Now that we've got our sample done, you can hear the soil scan is no longer running, or mixing I should say. We're going to take the solution off, and we're going to move the sample over here from the mixing rod up under the sensor. And then we're really simply going to hit another button that says start reading. Now that's going to take a few minutes to check the reading, and while it's doing that I want to come back and show you a couple things. So again, we've got the board that we used out in the field. Take this everywhere we go. Set that down. One of the things that we didn't do any video of earlier though is testing for some compaction. So this is a soil pentrometer. Again, I got this through Midwest Labs. Comes with a couple of different tips that you put here that you can screw on. And it's just a great tool to kind of figure out, or to start to identify what some of our problems are in the field. So as we were walking out there, we came upon a spot where the field is really super uniform throughout, and we came to a spot where everything was just a little bit shorter. And I said to Scott, is this a compaction problem? And he said, yeah, actually. And we got to look, and there were tire tracks and a little bit of wetness there. So you can tell that that was an area where the tires had caused some problems. But having a soil pentrometer on hand is a really handy tool to have an idea, because if you look at the top of this, you'll see that there's a gauge basically, and corn roots will start to grow laterally once they encounter 300 psi. So that's kind of their magic number for where they really say, hey, that's too much resistance. So it's just a good way to be checking your fields and saying, hey, is this or to identify possible other limiting factors. The other thing that I'll show you while this sample is still running is, again, we've got the 12-inch soil probe that we used out in the field. And then I also always travel with the 8-inch probe as well. And this I typically use when we're doing fall soil sampling, just because it's a little bit easier to go in the ground, and that's what we'll do for our complete analysis that we always run through the Conklin AgriVantage system. It's actually through Midwest Labs, and then the results come back through the AgriVantage system. So that's a really, really great tool to use. You get a complete NPK, but as well as all of the micronutrients, base saturation rates, CECs, organic matter, etc., etc. So just something else to talk about while the results are running here. And we've got our first set of results, and rather than telling you what those are, we'll actually post that when the video is all done, and you can kind of see all the way across the row how this ultimately shakes out. One thing I'm going to add though before we go to that is this. Remember that the SoilScan, while a great tool, does only give us the nitrate form of nitrogen. And so I've had a lot of growers say, well, what about ammonium? Doesn't ammonium matter? Yes, it absolutely does. And so a lot of times what I do is I encourage growers, once we run a set of samples like this, we'll take what's left over and we'll mix it up, and we will take a composite and we'll send that off to Midwest Labs. And the reason we do that is we'll ask for an ammonium only test. Now, the ammonium form of nitrogen is plant available, so don't forget that. So just because it's in the ammonium form doesn't mean that your plant can't get it. Quite the contrary. It means that it is a plant available form that's going to be held in the soil a little bit better than what the nitrate form is. Nitrate is use it or lose it. The ammonium form is plant available but also less mobile in the soil. So to get a complete picture, you do want to go ahead and send that off. Midwest Labs is great though. It's only $5.50. You're actually going to spend more on shipping it there than you will on the sample itself. And the reason for that is because what we found last year is when we would take samples and run them through the SoilScan and then take them to Midwest Labs or send them off to Midwest Labs, a lot of times the samples were coming back just a little bit higher in nitrate at Midwest Labs than they were through the SoilScan. Well, that makes sense because you get a little bit of conversion from the ammonium to the nitrate form if it's going to sit there in a sample bag, going through the mail, whatever, for a few days. So when you take your sample, you're going to want to take it, put it in the freezer. Ideally, you'd take it like on a Monday and you'd overnight it to Midwest Labs. That way you have less conversion going on. So that's what we're going to shoot for, so that we can get a complete picture of both the ammonium and the nitrate form as we're looking at our nitrogen. It gives us just a little fuller picture of what we're going to be dealing with through the growing season. So we just got our results back from the first set of samples that we ran, and this is actually the in-row sample. Should theoretically be right on top of where Scott had done his strip till. But it came back really kind of surprisingly low, given that he'd put 60 pounds there in his strip till. So what we're going to do is we're going to actually rerun this sample. And this is one of my favorite things about the SoilScan. People have asked before, how accurate is it really? Well, the answer is it's very accurate. In fact, it's so accurate that this particular machine, and some of them it goes through the ALP lab certification. So this SoilScan is ALP lab certified, meaning it's as accurate as a Midwest Labs, an AgVice, or any other lab that you might be using. And the beautiful part about this is occasionally, even at Midwest Labs or wherever else, you may get some result that is an outlier. The difference is, if you get some result that looks really, really weird, and you send it off to a lab, you're going to have to pull the samples, send them again, and wait a few more days to get them back. With the SoilScan, you can say, okay, is that accurate or is it not? We're just going to run from the exact same sample bag. You can run it 2, 3, 4 times, however much soil you have, and you'll figure out exactly how accurate that is. Now, the other option that we need to consider here is maybe that it's not the machine that's off. Maybe the strip till, the planting, and where we took the samples is not exactly in line with the strip till. And in fact, I just talked to Scott, and he said they were having a little trouble with their GPS. So as we go through and run all these samples, it's going to be interesting to see if he actually planted right on top of the strip like he thought he did, or if he's off just a little bit based upon where his markers were. He said actually that by the time he got to the end of the field, he was reading that he had been pushing it 3 feet. Was what he could be off. So, like I said, it'll be interesting to see where that comes back. Beautiful part about the SoilScan, we weren't sure about the results, so we're just going to rerun it.